Okay, thanks very much. And we really had a great introduction, I think, in some of the discussions that we've had through the morning. So I've kind of rearranged my comments here to fill in the gaps a little bit in terms of what we've talked about. So I'm actually going to start a little bit with history, because water reuse is actually a historic practice. It's not a new practice. And if you look at the sewage farms, for example, of Europe or of Australia, Western Treatment Plant and so forth, that's non-potable reuse, oftentimes for agriculture, non-potable because we lacked at that point the treatment technologies to upgrade it to higher uses. Potable reuse, really the instance that triggered potable reuse was a failed project. It was actually in the south shore of Lake Tahoe in California, in the Sierra Nevadas. But it was the first time that anyone tried to take sewage and turned it into drinking water, but it spawned 3 plants in the early 80s. So Water Factory 21 in California, the Upper Occoquan Service Authority in Virginia. If you've ever flown through, I think everybody here has probably flown through Dulles Airport, you have consumed product water from UOSA, and then Windhoek in Namibia in Africa, to just get the geographic distribution. So water reuse it's very common. It's more common than you think, because most water supplies have some treated effluent in them. So the idea that's perpetuated by the drinking water profession that all drinking water sources are pristine is absolutely false. So Madrid, I understand the water comes from the mountains. Vienna, San Francisco, New York City, these are the exceptions. Almost every water supply has some treated effluent in it. And particularly in Europe was the beginning of this, of treatment technologies for drinking water that are the same technologies we apply in water reuse. So riverbank filtration, ozone, and biological activated carbon and so forth. So there's a long, long history with the technologies that we use and actually the practice. But so either unintentional or intentional water reuse is a long-standing and quite well-developed practice. There's an interesting change that it really started in the Millennium Drought in Australia, though, because historically, potable water reuse was viewed as the water supply of last resort. There's nothing else we can do, we'll reuse. The thing about water reuse is that water supply is always there. So the idea of a portfolio of water supplies, and this was really crystallized by the Australians in the Millennium Drought, that a resilient and sustainable water supply has a variety of sources, and that water reuse and potable water reuse is an essential component in many, many locations, because it is the most reliable supply. I think also when you look at water reuse, it's important to understand, because folks say, well, this is so expensive because of the treatment. You have to realize that you're solving 2 problems. You are creating a water supply. There's a lot of money associated with that you're offsetting. The second thing is you're actually solving an effluent disposal problem. So when looking at reuse, you really need to look at the whole picture in terms of not only what does it cost for this treatment, but what are the broader benefits, and I'll come back to that in just a minute. Now, there's a well-established practice for water reuse, both non-potable, but especially in the last couple of decades, now a well-established professional practice in terms of potable reuse. And we think about the treatment, and there's actually two approaches to treatment. We've talked a lot about reverse osmosis. There's also what people call the carbon-based system that at its heart involves ozone and activated carbon operated first in a biological, then in an adsorption mode. And if you look at throughout Europe, you will find drinking water plants that do this also because because they're removing the same constituents. But there's two other important components of this professional practice. One is source control. So developing and rigorously implementing a source control program to keep troublesome materials, both industrial but also commercial. So regulating dry cleaners, for example, to keep acetone out of it and so forth, is an important component. So regulating the quality of the raw material that's used for water reuse is a very important component of this. The second is the monitoring and the day-to-day control. So there are many that think that, well, it's controlled by monitoring the quality of the product water. Yes, the product water is monitored from a quality assurance perspective, but the day-to-day and the minute-to-minute control is about verifying that the technology is operating. So a potable reuse facility is really operated as a factory with established operating procedures, rigorously implemented quality control to ensure that the technology is performing, and that technology, before the plant actually comes online, the specific technology is verified to provide the removal that's needed. A treatment train is put in place that removes a wide range of contaminants. And all of this goes into the established professional practice. So, and it's really those things, the source control and the operating procedures, that really has not just the treatment technology that makes this quite frankly, a very safe. The water that's produced from a potable reuse train is measurably better than drinking water. By every measure, it is better in terms of quality. The control is more rigorous. So the analogy is you're safer in an airplane versus a car, even though an airplane is more dangerous. So the bigger the potential issues, that's compensated by increased scrutiny and increased control. But it is absolutely a fact that the water that's produced out of a well-run potable reuse facility is better than drinking water. The last thing is acceptance, and this is also an area where significant progress has been made. David Sedlak has actually done some very nice work, among others, about legitimacy. So there would be those that say that all we need to do is to educate the public, and that potable reuse facilities will go forward. That is absolutely untrue. Acceptance is not about knowledge. Acceptance is about emotions. And if you if you need a potable reuse facility today, you're too late. You need to start about a decade ahead and building the legitimacy and the credibility, the legitimacy of the practice and the credibility of the organization that's going to implement it. And how to do that is also relatively well known. So I'll stop with that.